SES students, I'm Jessie Kaylee. I work for the city of Eagan. I went to school in Michigan. I got a biology degree at Hope College in Michigan, and I got a master's degree in fisheries and conservation biology from the University of Minnesota in the Twin Cities. And for the last dozen years or so, I've been working for the city of Eagan. Now I'm their water resources specialist, so I do a lot of the field work. I do a lot of the water samples, fish sampling, stormwater monitoring, and when there's a spill or something on a lake, we make sure that that gets cleaned up. There's a lot of mapping that goes into this. There's a lot of talking to the public, so you have to be a good communicator. Today I just wanted to show you a quick introduction for water quality sampling that I would do, and this is what you would normally do some of in your pond profile. And this year we're going to be a little bit different. I got you balanced here. You can't see the lake, but you can believe me. I'm on Carlson Lake in Eagan. There's a lot of different kinds of water sampling computers and devices out there. The one that we have right now is called a Hydrolab HL4. I have an anchor that I'm going to drop so that I don't float all over the place. This here is the cord and the probe end of the HL4 Hydrolab that I was talking about. There's some computery bits up here that won't get wet inside this casing. And then there's a bunch of different sensors here. So there's place to measure pH and conductivity and oxygen. This long thing with the stirrer on the end is a turbidimeter. So it measures basically how far light can travel through the water, which can be important sometimes. It measures depth and temperature. I'm going to put that part down in the lake, and I'm going to go right to the surface here, kind of step on it with my foot so that I'm sure it's going to stay where I put it. And then I'm going to turn on the computer end. This is the cable that's hooked up to the other side. So click it on, and it just takes a second to wake itself up. And once the reading is stabilized, I hit save, and then I would lower the probe another meter and hit save. And I do that throughout the profile of the lake. That's what we call from top to bottom as the lake profile. And then I'm also going to fill my bottles with lake water. We're gonna send these to the lab to test for chlorophyll and nitrate and nitrogen and phosphate and total phosphorus. And those things tell us a lot about the lake. Okay, so I've got my water sample now. I stuck my core sampler tube into the water vertically and put my hand over the end like I was trying to keep the fluid in like you would do with a drinking straw, right? And then I dumped it into the bucket. Did that a few times, so now I have enough water. You probably have a depth measurement tool like this. It looks like a little flashlight. Apparently they float. So you put this end is the part that points down into the lake. And when you click it on once, you can see that it's turned itself on, maybe. And then when you hold it straight up and down into the lake, then it gets back a little signal, and you can see this reading says 19.3. I usually do it a few times because there's a little bit of variation. 19.3, 19.3. Okay, not much variation. So I'm gonna write in my notebook that it's 19.3 feet. So this box contains our Kemmerer sampler. It's named after someone, and it's a deep water sampler. You put it down into the lake vertically, so then you can grab a deep water sample at whatever depth you like. You guys will do the same, only with a sort of horizontally positioned Van Dorn sampler. I would put it down as far as I wanted into the lake. There's markings on this rope so I know how far it's going down. And when I want this to close, you can just pretend that this sampler is quite deep. Then I would let this go. Clunk. It hits the top, and now the thing has captured our sample of water. I can put the rest in there, and then that would be my deep water sample. The Secchi is a really important thing to measure because it's easy to measure. It's easy to be consistent with, so you can use a lot of good volunteer data. And also, it tells you a lot about the types of water quality that you're dealing with. You lower it in the water. It's a good way of telling the color of the water as well. And then I got to about 7 feet here before I could really see it disappear. So I lift it back up, and the point when I can just see it, that's about 7 feet. And I usually go to the nearest half foot. Being outdoors and just getting to see the sights and sounds and touching the water and touching the fish, you know, that's really, it is a big perk of the job. If you are thinking about a career in the environmental sciences, I recommend it. I think it's much nicer to have at least some fieldwork time outdoors than spend your whole life in an office. And I'm one of the lucky ones that gets to do that.